Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com program, brought to you by Techstrong. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation for you ahead. First, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our session, or you would like to rewatch or maybe share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you are joining us. We also have a couple of polls throughout today's program. We'll have one towards the beginning and two scattered out throughout the rest. So we want your participation there. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is container storage, rise of stateful apps. And I'm joined by Ivan Fetch, developer at Fairwinds, and Mike Vizard, Chief Content Officer at Techstrong Group. Ivan, Mike, thank you both so much for being here. Mike, I'm going to let you take it away.
All right. Thanks, Cody. It's a pleasure to be here as always. Ivan, hope you're well. Let's dive in. What do you say?
All right, let's do it.
I don't think back when we first started talking about container storage and Kubernetes that there would be a topic that would generate so much religious debate and fervor than this one, but it kind of took me by surprise, actually. But back in the day, at least, there was a lot of folks who adamantly said you can only run stateless applications on Kubernetes, and you should never run anything stateful because eventually you just wanted to store the data off the cluster. And of course, stateless apps have to store data somewhere. But the argument was stateless apps are off the hosted off the cluster, and we won't run stateful apps on the cluster. Moving forward to today, we're in a scenario where we're starting to see a lot more stateful applications deployed on Kubernetes clusters. So what's driving that shift, that mindset, and when to do it and when not to do it? What's your sense of where we are in this journey?
Yeah, I think there's a few things that come into play. I think that a lot of parallel things continue to mature or grow and evolve. So I think that Kubernetes has been around for a while now, and Kubernetes has made some awesome improvements in supporting storage and bringing those storage constructs into the Kubernetes APIs. Also, I think that more and more folks have begun using Kubernetes and have migrated their stateless apps and have begun operationalizing and automating and building their internal knowledge and perspective on Kubernetes. And that increases the comfort with Kubernetes as a platform, all the options that it provides, and using it as a business. And so I think that compared to how things felt a few years ago, where Kubernetes was simply a lot newer, and frankly, I think folks were kind of waiting to see which way the wind might blow on some level, which container orchestration is going to quote unquote win and that kind of thing. I think that we're at a different place now, and Kubernetes is certainly not the hammer for every nail, but there's a lot more folks with a lot more experience, and they've migrated those stateless apps, and they're a lot more comfortable, and so they're starting to become ready to tackle that state now using Kubernetes. We definitely recommend tackling stateless apps first. There's plenty of challenge there, and it lets folks get up to speed with operationalizing Kubernetes in their org, making sure that not just the POC team is comfortable with how to use Kubernetes, how to troubleshoot Kubernetes. And we have a maturity model that we've worked on in conjunction with the CNCF that I highly recommend taking a look at if folks are interested in looking at more on some phases that we've seen as a company that tend to be common through folks' life cycle working with Kubernetes. And we feel like folks are hitting higher and higher on that kind of rough model, and they're ready to start looking at state. So, and I also think the other factor, Mike, is that, data is what typically folks' businesses rest on, right? So not that your apps aren't important as a vehicle to access that data, but if you lose your data or if your data becomes less accessible, that's a whole different level of concern, I think, for businesses. And so it also takes some of that, some time to have folks build their comfort and build their readiness on all these other platforms to be able to start considering, okay, we've done these things. Are we ready to start moving our data into this platform too?
All right, well, let's run a poll here real quick to see where everybody is in terms of our attendees and where their path of adoption is. So let's go. Does your Kubernetes journey include stateful apps? Please answer. We are planning the migration of our first stateful apps. We've started running stateful apps in Kube. We are successfully running stateful apps in Kube already. And then we'll wait a couple of seconds for people to kind of figure out where they are and give us an answer. And see where we go. All right. Cody, you think we're ready? All right, let's just see where our answers are now. Does your Kubernetes journey include stateful apps? We are planning the migration of our first stateful apps as a clear winner at 50%. We've started running stateful apps in Kube at 39%, and only 11% said we are successfully running stateful apps in Kube. So it looks like there are folks that have some challenges to work out, as they say. Ivan, what makes container storage difficult? Is it more difficult than other forms of storage? Is it more challenging? What are some of the issues that people run into or should be thinking about? Or as they say now, what do you know now that you wish you knew 2 years ago?
Yeah, I think there's a few factors. One of which is that it's a continuing. This is continuing to evolve, which is a good thing, but there's often some concern, I think, around if I'm going to leverage an aspect of a platform, if I'm going to put my data on Kubernetes, I want to feel like that landscape is, time tested, quite a bit more so than I might be concerned about running something that is more ephemeral. And so the first point here is that containers are in Kubernetes largely a ephemeral product. So not that it isn't possible to do other things, but there's a big sell and a big push for understandable reason on containers being ephemeral in Kubernetes. Build your app so that containers can move at any point in time. It's okay if those containers get stopped and moved to a different Kubernetes node as part of cluster upgrades, or if the container is exceeding thresholds like memory limits, that Kubernetes will kill that container and it'll be restarted, potentially on that same node, potentially on another node. So wanting applications to be resilient to that model is something that we've been thinking about in the Kubernetes landscape for a really long time. And as a juxtaposition to that, storage and data that your business really cares about is something that you want to be very persistent. So containers being particularly portable and particularly scalable is a very mixed mental model, I think, with data, which takes a little bit different time and effort to scale data and to move data to copy. It takes time to copy that stuff to, let's say, another storage node or another availability zone in cloud, and so on and so forth. Also, there's scaling that doesn't quite work the same way. So you can scale an application in Kubernetes by, as long as your app is scalable, moving pods or increasing the number of pods that you're running. If you have a pod that's running a database of some sort in Kubernetes and there's storage behind that, you can't just add more pods to access that same piece of data. That database has to scale out in a database application way, right? So how to do that in a way that is supportable in Kubernetes adds additional layers. And so those layers bring complexity both to the Kubernetes platform, depending on what the Kubernetes platform team has experience with. And it also potentially, depending on your organization, is going to merge disciplines a little bit. if you've got a storage group, traditional data center background, somebody that's provisioning lungs on storage arrays and zoning, fiber channel switches and that kind of thing. And now all of a sudden you're wanting to bring storage into the realm of containers and Kubernetes. It's similar, I think, to the story that a lot of us experienced in virtualization, where there's a bit of convergence that happens there. And that requires time and effort and a little bit of adjustment, perhaps, in an organizational way. Some folks need to have a few chats about how do we cross-function these teams, if you will, in order for all of this stuff to come together technically and for it to come together within the organization. So there's a lot of pieces there I kind of rattled through, but I think all of this comes together to sort of make the storage / containers picture certainly feel a lot more complex. And there's a lot of pieces to work through there that are going to be a little different for everybody.
You mentioned that there's been a lot of work on the Kubernetes APIs for storage. Is that work done? Is it still a work in progress? Where are we in terms of the capabilities of those APIs? Are they fully robust?
It's still a work in progress. I think there's still a lot of great improvement happening. One of the most notable, I think, is moving the code that helps Kubernetes be storage aware and connect with storage arrays or connect with volumes in cloud and be able to move the storage constructs and concepts up into the layer of the Kubernetes API. A lot of that stuff has been moved from what they call in tree, which is essentially where that code is some part of the Kubernetes code base. It's moved from there to the CSI, the container storage interface. So some of that work is certainly still in process, but it's a great example of the increased flexibility and mobility of storage access to Kubernetes being moved into CSI drivers, which means that it's easier and in some ways more straightforward for storage vendors to create these provisioning plugins to help you be aware of and manage storage in Kubernetes so that you can have resources added to the Kubernetes API, often through CRDs, which is custom resources in Kubernetes, to help Kubernetes be aware of maybe a new construct or a variation on a theme. Maybe you're a storage vendor and you do snapshots or deduplication or replication in a somewhat special or unique feeling way. And you can reflect that access and visualization, if you will, in your Kubernetes plugin. So those APIs are definitely still, kind of a work in progress. They evolve like the rest of Kubernetes API with deprecations and eventual removals of aspects of the API as we all learn and grow and experience running storage in Kubernetes in real life. And realize that as we're abstracting storage stuff in the Kubernetes API, that there might be a better way we could do it, and so on and so forth. So there's some things that I'll also talk about that to help maybe paint a little bit more of a picture for the folks that are still kind of exploring what does this landscape look like getting into storage in Kubernetes, since we saw some pretty good numbers there in our first poll. When you are making storage available in Kubernetes and you're using these plugins and these providers, to think of them kind of as drivers for accessing storage. Storage becomes a resource in Kubernetes similar to how a pod or a node is a resource in Kubernetes. And so you can have storage classifications, as they're called, that can represent things like the speed of your storage, maybe SSDs or slower disk, location, shareability, like things like NFS, if you can have multiple read-write access to that storage, and so on. So these Kube storage plugin interfaces interact with storage arrays, or they interact with your cloud, like AWS or Google or Azure, and so on, to help you provision volumes as you need them with the given characteristics that you require. So as you request storage from your pods in Kube, you essentially ask for the traits of storage that you like, and these storage plugins can help you get the storage that you need. And so these APIs help handle storage pretty well in a system that's otherwise, like I mentioned earlier, been primarily ephemeral so far in the past.
Let me ask you a follow-up to that specific question. Is also part of the benefit is that, at least as I understand it, I can upgrade the Kubernetes cluster in a way that's not as disruptive as it might have been in the past, because these APIs exist and there's a level of isolation now between both sides a little bit. And I can actually run maybe cluster farms that consist of multiple versions of Kubernetes and not have it disrupt my storage architecture too much. I mean, what is the level of interplay there?
I think that what helps that the most is the more connected, or the more tightly we can couple awareness of storage resources. So there's a bit of a wavy line here, right, where we're abstracting storage in Kubernetes, and we want to abstract it in a way that the folks using Kubernetes as a platform don't necessarily have to know storage admin level stuff. But we also don't want to abstract it so much that, to your point about things like cluster upgrades and interoperability not causing compatibility issues and that type of thing, we don't want the abstraction to be so kind of flexible and fluffy that it causes us problems there. So what I think that we're gaining as these abstractions have improved and continue to do so is that, to the point of your question, you're able to have Kubernetes be aware enough of the storage that when you're doing things like cluster upgrades, you don't have to care so much about doing quote unquote special things or extra prep or being extra aware of, well, it's all well and good when you upgrade this Kubernetes thing, but you have to give some special care and feeding to this storage beforehand, or something's really going to blow up. As far as having like multiple Kubernetes clusters and maybe different versions of Kubernetes, I'll talk to a single set of storage. We can feel free to follow up if I go in a direction that's not what you were intending for that part of the question, but that's pretty much doable. You're of course not going to share volumes as likely across, if you've got something that's read-write, you could share it across multiple clusters, but I don't see there being as much of a likelihood that you would do that. So you might have multiple clusters of different versions talking to the same storage array, or talking to the same overall cloud account that accesses storage, but you're still managing like independent pieces of storage or volumes or snapshots from one cluster to another.
Yeah. Well, we have a question from the audience already, and I want to encourage everybody else to start typing in those questions in the chat session and the Q&A. But our question is, someone is not quite sure how storage is going to be reattached to a pod when one is being replaced. So how do I kind of keep the consistency of the environment as there are upgrades?
Yeah, so this is going to depend a little bit on the implementation details. I know it's always potentially irritating when someone says it depends ... even though it's often true. So I'll still try to be broad about this in a way that will be useful to you. So it's going to depend slightly on maybe what cloud you're deploying in, or if you're in a data center. But the way that works in terms of volume attachments when pods get replaced is that often in cloud, if you are using Kubernetes storage that manages cloud volumes, and you're not using some other options like hyper-converged storage, where the storage is really running on the Kubernetes cluster itself, which I think we'll get to in a bit. But if you're just having your Kubernetes cluster manage like cloud block volumes as your storage, the way those attachments work is that when a pod is deleted or dies in some way and has to move to a new node or has to restart on the same node, the volume that is associated with the storage for that pod gets detached from the old node if it's moving nodes, and then attached to the new node where the pod is about to be restarted or start running that container. And then once the volume is available on the node, Kubernetes takes care of mounting that volume in a traditional, like how you would mount a file system on a Linux box. And so then Kubernetes is able to access that volume device, and it mounts it for you inside the pod, so that the container can then have access to that mount. So there's a situation here where if you are potentially losing an availability zone in cloud, often that volume ends up being stuck to the availability zone that it was originally in. This depends, somewhat on the cloud architecture and what's available in cloud block storage. But the point I'm calling out here that's somewhat important is if you have pods that are spread across availability zones, and for some reason you can no longer run a workload in an availability zone because you had like an AZ failure in cloud, you might end up in a situation where that volume is temporarily unaccessible because the AZ is unaccessible. And that's why it makes it's important to have your storage and the architecture of, let's say it's a database that you're running in Kubernetes on top of that storage, still be redundant. So even though Kubernetes helps your application heal and restart and fail over and scale, we need to make sure that the database is also still scaled as an application. So for example, you might have 3 replicas, 1 per availability zone. They would each have their own volume. And if you lost an availability zone, you would still have those 2 other replicas, but now you would be running in a degraded state. So I'll stop talking there. Hopefully that's enough information that not only answers your question, but gives you maybe a bit of a glimpse into where this might be headed for you.
Oh, that sounded great. Thank you. Are there kinds of best practices for when I should try to store data within the cube, or when I should be accessing some sort of external service? I mean, does it depend on, I don't know, application latency? What might be the issues of the day that decides one way or the other?
Yeah, so as far as I'll talk about external storage first, because I also think that is a helpful way to start, and it's a little bit aside from the primary point of most of the things we're talking about here. But I think it's a good question, and I think it's worth spending a little bit of time on external storage first. So I think if you're not already running quote unquote hyper converged storage, which basically means you're leveraging your Kubernetes platform also as a storage platform. If you're not already doing something like that, I think it makes good sense to consider using externally managed storage, because it can reduce a lot of the burden on your teams. Burden from a management perspective, just simply needing to run more things, something else that you have to troubleshoot, et cetera, et cetera. So, if you can use things like highly available cloud object storage, NFS, block storage, and if that works for your application in terms of the latency that your application is happy with, and what kind of IOPS of storage your app requires, then I think that's well worth starting off with. It's similar to our recommendation to start with stateless apps when you can in Kubernetes. And then when we see people foraging into the world of storage in Kube, we recommend that it starts with, okay, run a stateful app in Kube, but try to have the storage not be part of the picture of what you have to manage. It lets you chop that up into more bite-sized, approachable pieces, I think. Now let's talk a little bit about hyper-converged storage a little bit, which is the other side of that coin of your question there. I think that hyper-converged storage definitely provides you with more flexibility and also, of course, way more responsibility. And I'll talk a little more about hyper-converged storage. I've said a couple of times broadly what that is, but hyper-converged storage is essentially using your same Kubernetes platform and various infrastructure to also run storage as well as the apps that you're already running. Now, that doesn't mean that you have to share the same Kubernetes nodes to manage your storage and to manage your apps. I think it's nice to separate those out a little bit so that you don't have contention there. But generally, hyperconverged storage is going to let you use a product of some sort that's running on top of Kubernetes. So that might be something like the Rook product, for example, which gives you block storage and object storage and shared NFS-like storage using another open source product called Ceph, which some folks have likely heard of and are likely familiar with. And it runs that storage layer on top of Kubernetes itself. So you're getting to use the Kubernetes platform you already have, the redundant, tested control plane, that management layer of Kubernetes to help get things from their current state to the state that your users desire. So that same technology that we use to make sure that the same number of pods that we want to be running for an app are actually running. And if some of those pods experience issues, that Kubernetes helps them heal, that same control plane can be used to help us manage the storage itself. And there's a few ways that you can choose to go about this. There's a lot of detail behind all of this. You can have local disks in your nodes that are used for this storage, and then replication happens between the nodes. If you're okay with the latency, you can still use cloud volumes or storage array volumes behind that, but still have the hyper-converged layer helping you to duplicate data and do replication and snapshotting and all that kind of stuff. But hyper-converged storage is going to let you leverage your Kubernetes platform, and it's going to give you the most options. But now you're in the business of Kubernetes is also your foundation for storage. So it's something you definitely want to be ready for. If you've got a Kubernetes team that's still operationalizing Kube in your org, they might have a big panic look in their eyes if the next step is, hey, we want to lay storage on top of this foundation, which might still be being fortified and built for your org. Also, when we say external storage, back to this previous point, I think we sometimes also mean managed by another team. And that can help in the situation I just described, where maybe the foundation of your Kubernetes platform team and their experience troubleshooting and fighting fires and all that, might not feel quite ready yet to add converged storage on top of Kubernetes.
All right, well, Cody, let's go to our next poll here, because I think it's related to this whole conversation in the first place. So here we go. Mm-hmm. Our question is, where do you think the state should live for Kube-hosted apps? First choice is outside of Kube, pods get data from external services. Second choice is outside of Kube, pods get data from cloud or array-hosted volumes. And then finally, we have inside Kube, leveraging Kube to deliver storage to pods. Question then becomes, maybe in some folks, it might be all the above for all I know, but let's wait for some responses and see where we go.
Yeah, while we wait for those responses to come in, I think you're right, Mike, that that question isn't meant to imply that it has to be only one of those things. In fact, I think it'll likely be somewhat of a sliding scale as folks move their journey along with storage, starting out with the left side of there, and then kind of moving along to maybe using hyperconverged.
All right. Well, let's see what our results suggest here. All right, we've got 54% of folks are saying inside Kube, leveraging Kube to deliver storage to pods. And then we have 33% saying outside of Kube, pods get data from cloud or array-hosted volumes. And finally, only 13% are saying outside of Kube, pods get data from external services. Ivan, does any of that surprise you when you think about those results?
A little bit related to the first poll that we saw, right, where folks self-identified as being earlier in their storage journey. So here we see 55% of respondents, saying, go big, right? Leverage the Kube platform for storage. So only as it relates to the previous poll is it a little bit surprising, but it is definitely when you are wanting to have the most control over how you scale your storage, how you manage your storage. Being able to add nodes to a Kubernetes cluster that ends up resulting in having additional storage or additional redundancy available to your storage that your also kube hosted apps can leverage. It is a very powerful thing. So we're getting to leverage all these advantages that Kubernetes gives us as a platform, as the sort of underpinning to running a storage system, which means that the storage system doesn't have to have, the Kubernetes control loop that we always reference, where it's looking at the current versus the desired state of things and working to make that so, right? Things like Rook as a project have a Kubernetes operator that is aware of how to manage things like Ceph to make things happen on the storage layer, to make the custom resources in Kubernetes that represent things like, I would like a Ceph cluster, please, in Kubernetes, and I would like this volume, or I would like that NFS store, or I would like this object store similar to S3. And the operator that runs in Kubernetes knows how to make that happen behind the scenes. So it's, and the operator pattern is broadly like accomplishing storage operator, quote unquote, type tasks. And it doesn't mean that the storage operator has nothing to do, right? It frees them up, in my opinion, to manage, other layers of this and to be able to scale themselves and their storage at a more incredible rate. But the operator pattern is essentially providing those operation functions for you in that Kubernetes platform. So while I'm surprised that 55% as it relates to the previous poll, I'm not surprised that this audience is seeing where it's at in terms of the ultimate flexibility and power of taking control of their storage.
Do you think that some folks are looking at greenfield applications and simply don't have access to any kind of external storage beforehand, so they're just putting everything on the cluster?
Maybe. I mean, I feel like there's always the potential of, if you're in cloud, there's always the potential of some kind of managed service that you could consider. But there's a lot of reasons why folks don't want to do that, right? We could get into the whole lock-in debate and what's really lock-in if you want, but maybe that's another webinar. But I think that one of the advantages of running storage on a platform like Kube is that, like other things that we can run on Kubernetes, it can become the platform to sort of overlay multiple clouds. Again, another thing that we could talk about or not is sort of, what's really the deal with multi-cloud? Is multi-cloud really a thing? But if you're wanting to have a unified type platform that you can manage, similarly across multiple environments, even like cloud versus data center, Kubernetes and hyperconverged storage can give you that. So I feel like even greenfield stuff, there probably are options, I think. But I suppose if you're greenfield, it's also a pro for, well, if we're going to learn and do all this stuff anyway, maybe we just start with where we want to end up. That can often be like a pretty big undertaking, but it's definitely doable. Frankly, for better or for worse, it happens to be where I find myself leaning. And sometimes that might be considered over-engineering a thing. It really just depends on how much time do we have, what kind of MVP do we want to get out there. There's a lot of factors there.
Sometimes it is better to jump in the deep end of the pool. Hey, I wanted to ask you something. You mentioned Rook a couple of times, and I don't know if everybody watching this knows what Rook is. So maybe give us a couple of minutes about what is Rook and what does it do and where does it fit?
Sure. Hopefully, I think I probably gave a pretty good kind of high-level explanation of that. So this might be a little bit of repeat, sorry for folks, but so Rook is a Kubernetes operator itself. And so when you install Rook into a Kubernetes cluster, it basically gives that Kubernetes cluster additional resources and additional awareness of some new things, like Kubernetes already knows about pods and nodes and deployments and stateful sets and those kinds of things. And once you install Rook, Kubernetes is also going to know about things like a Ceph cluster and the resources that a Ceph cluster can provide, and it helps you manage those things. And what a Ceph cluster, CEPH, gives you is Ceph is a storage technology that has been around for quite some time, and it's been used in a lot of data center environments to provide distributed storage on multiple nodes with disks in those nodes, and those disks can get chopped up as different kinds of storage, whether it's block device volumes or shared storage like NFS, or emulating different kind of block storage and that sort of stuff. So Rook is helping you manage Ceph as one of. It helps you manage other stuff, but Ceph is really the thing that I'm familiar with it doing. So Rook helps you manage Ceph as the actual provider of the storage technology and those different kind of volumes that I described. So now what you can do is you can have a Kubernetes cluster with X amount of nodes, and those nodes have some disks attached, whether they're local or whether they come from cloud, if that latency is okay, or whether they come from a fiber channel storage array in a data center or whatever. And Rook via Ceph will manage the provisioning and replication of the data and all of that through Ceph. And so it's this sort of stack. Maybe it's turtles all the way down. I don't know. But herein are those multiple layers that I referred to a few times of, if you're going to do hyperconverged, then there's all these layers that you probably are going to want to understand. Ideally, you don't have to understand as much about Ceph, because that's Rook's job, is to help you manage that. But I think, as we all know, there's always cases where there's an abstraction that works wonderfully until there's a situation that comes up where I now have to understand what's happening behind the abstraction. So, depending on the org, the use case, the complexity, how big your app is, how much you're pushing the storage, what your architecture is, all these variables, you might find that you want to know a little bit about, well, what is Ceph, or what is it doing kind of behind the scenes as managed by Rook, if that makes sense.
All right, that sounds great. You mentioned the different types of storage that are out there, file, block, object. Are you seeing more of one type versus another on Kubernetes, or does it lend itself more so to a particular format, or is it all over the place and even Steven?
I think it's pretty spread. I think it really depends on the app. So I think that if you're using cloud-hosted storage, for example, and you're not doing hyperconverged yet, object store has always felt more scalable and flexible to me than, for example, going in an opposite direction of having a shared file system, something like NFS, where you can mount it, read write across multiple pods and nodes. So if your app is accessing objects and it can talk directly to object store, that's not really hosting storage in Kubernetes anymore. But I think that's a good example of, depending on what the app needs and what the app supports, it's of course going to drive what kind of storage do you really need. You may need to re-architect some aspects of your app to be potentially more flexible or less leaning heavily on how it accesses its storage. So a classic example of that I've seen in my past is, you might have an app or multiple applications that use a shared file system, something like NFS, to store their app data, but maybe even interface with one another. So you might have two applications that read and write content to the same data store, and instead of those applications talking to each other using an API, like HTTPS or gRPC, they're kind of communicating by writing and reading files to this data store, which can make migrating and containerizing and moving that app around and making it portable a little bit more challenging, versus if we were to take those apps and do some re-architecting and have them talk to each other with APIs and have their data be somewhat separated, and maybe most of the data those apps use are some kind of individual data files that could be objects in an object store. So that's what I mean when I say there might be a little necessary re-architecture happening to help your app be what we tend to call "quote unquote" cloud native, right? So really the answer to this, what kind of storage do we see? What kind of storage is appropriate? I think it's really going to depend on the app, and sometimes we see apps that maybe use the wrong "quote unquote" wrong or less ideal is maybe a better way to say it, type of storage for where that app is headed in a container Kubernetes world.
As we go along here, do you think that microservices-based applications that are stateful deployed on Kubernetes clusters are more challenging to optimize from a latency perspective, or is the system getting smart enough to handle that for us? Because I feel like a lot of these applications are more latency sensitive because of microservices, but what's your sense of just how much of a performance expertise do I have to make all this work?
I think that what's changing is, to some degree, as we move things to the cloud, not all disk is quite the latency that we might be used to seeing in the data center. This is very subjective because it depends on, what do you have in your data center. But I've seen cases where apps move to the cloud and how storage is designed or used on the cloud might have more latency than the application owners are used to in the past. And so sometimes that bubbles up issues that maybe weren't felt as much before. And so I think that this latency question, I can't say that it's never the case that because they're microservices that's changing the latency pattern, but I think that's going to be pretty application specific. So the only real general answer that I think I could give here is that it's probably more a function of as you get more applications. So you take a monolith architecture and you move it into a pile of many applications. And now all those applications are having to communicate with each other. And depending on how those individual applications read and write and cache data or don't cache data, I think that whole picture, all of the microservices acting as a whole together compared to how the monolith application might have acted in terms of storage, IO footprint and stuff like that. It creates a different landscape for what that latency and what those IOP requirements are. And so, the answer to that is, heavily application specific, and it's looking at the architecture and how do things talk together, and do we need to have less latent storage behind certain microservices because of those things I just described, how they all talk together. And maybe there's a microservice that's a hotspot, and that data was accessible in a different way in the monolith world, but now because of how everything communicates, we're querying this microservice a lot, and do we need to use some kind of in-memory cache? So it's all over the place, as evidenced by how I'm answering this question in like 15 different directions.
That is fair. Let me ask you this then, because you mentioned hyperconverged. So who's in charge of storage these days? Is there a storage administrator, or is everything being converged around the management of one IT administrator who handles compute, storage, networking, the whole 9 yards, or do we still see storage specialists?
I think that it's going to probably depend somewhat on how hybrid data center cloud the environment is. Do you already have storage specialists? I think that maybe this is just because this is the world that I came from and I have a bias here. I think that it's still helpful to understand a bit about how the storage is working at the end of the chain. So when we're done with the hyperconverged layers and cloud and AWS EBS volumes, technically use network to connect to this managed storage service by AWS. But at the end of the day, there's still disks involved. And how do we improve IOPS using the managed part of that service? How do we improve IOPS by striping like we used to? At what point does that fall over? I think there's still help and value in having some of that knowledge on a team. So I think if you are hyper-converged, like we've been talking about, that likely you're going to have your Kubernetes platform team, your Kubernetes subject matter experts are probably now going to be part of this equation. That's not to say that you won't grow so much that you have storage-only Kubernetes clusters or storage-specific nodes in a Kubernetes cluster, and that you wouldn't have storage experts. But depending on the size of your org and how you're growing, your rate of growth with all of this, I think it's pretty likely that your Kube team, the folks that have sort of spearhead and led your other Kube efforts, are likely going to be involved here as well. And then if you've got storage admins, if you've got network admins, part of, I think, the hyper-converged definition is that you're also combining teams, and you're kind of cross, you're building cross awareness and training, and that's really important to not underestimate as well. When you're moving forward on these kinds of initiatives, I think it's really important to remember how having there not be hotspots in knowledge is really important. And it's very tempting to move full speed ahead and be like, well, it's running and it's working. We have 2 people that understand it in our team, and that should be fine, right? And those people can just be on call, every other week or whatever. So I think it's really valuable to make sure that you've got cross training that happens, and you involve all of these teams. And it might mean like what we wanted DevOps to be originally, right? Where we're taking a couple teams and we're having them integrate and work together. And it might mean reorganizing teams, but I think it's definitely a hybrid model for sure.
All right, well, let's go to our final poll because it's
right
on this topic. Cody, here we go. Who should manage Kube hosted storage? Your choices are traditional storage admins. Second answer is the folks maintaining the Kube platform. The third answer is teams that deploy and manage their own apps. All right, folks, let's see what we got here for answers. Give everybody a couple of seconds. Ivan, how do you think that's going to play out?
I kind of feel like it's going to head towards the last answer there. The folks managing the apps themselves are also going to manage storage, and I'm weighing a little bit on the previous answer being so pro for hyper-converged. It goes hand in hand. I think that if you're going to run that in your org and have storage be a scalable part of your platform, it makes sense that storage becomes self-serve essentially. So that's my guess. We'll see.
We'll see what the answers are. The bookies are laying odds in Vegas as we speak. All right, what do we got? We got at 53%, the folks maintaining the Kube platform, followed by traditional storage admins at 32%, and the team that deploy and manage their own apps at 16%. Ivan, that would suggest that maybe we're not seeing this whole full stack shift left application developer kind of mentality, but what's your take on the results?
Yeah, I don't know. I wonder if that difference in response is connected to the comfortability operationalizing, adding storage to this platform. So even if a lot of folks want to run hyper-converged storage, there's still a big step between running it and letting it be self-serve. So, and I definitely don't blame folks for that at all. I think that having the sort of like culture and comfort and the paradigm shift is large for a lot of organizations to say, okay, you want storage, go push this button and we'll give you the storage that you want. It takes effort to make a platform interface, if you will. And I don't mean that necessarily literally like a UI, but even just to be able to like classify storage in a way that's meaningful to how applications are designed and deployed in an organization. So there's a lot of moving parts there. If you run an application that does X, Y, and Z, knowing what that means in terms of storage is not necessarily something that an application developer should be deciding, depending on their level of comfort. and how the business also feels about that. So it's, again, something where everybody has to work together. So it's interesting to me. If anybody wants to comment in the chat, or I guess the chat would be the best place, or ask a question in the Q&A. I'm curious if folks have things to say about the difference between I'm all in on hyper-converged, but I'm not quite ready for storage to be self-serve yet.
All right. Well, I suspect it's all going to be a team sport. There's a roadmap for Kubernetes that's published and regularly. Is there anything in that roadmap from a storage perspective that you're excited about, or what do you think is coming next? Or maybe someday, who knows, AI will save us from ourselves. But as you kind of get your crystal ball out, what are you looking at and going, wow, I can't wait for this to happen?
Just, I think that I don't have anything particularly. There's this one item that I think would be amazing. I'm really excited about just what the progress has looked like, and I think that if we can continue to support the folks that are doing the work of converting things to CSI drivers, and continuing to support this open source development that is bringing the exciting work of bringing storage constructs closer and closer to the Kubernetes API. So one example of something that I'm not necessarily saying is coming, but I can think of right off the top of my head of that underscores what I'm trying to describe is you have things in the storage world like growing a volume, for example, resizing a volume, making it larger. That's possible to do, but it's not necessarily exposed in the most native way in the Kubernetes API. So sometimes the way that growing that volume has to happen is you do some magic where you kind of temporarily disconnect the stateful set from its volume, and then you grow the volume, and then you change the stateful set and you reconnect it. But that's a little bit messy and it feels scary, right? So things like that where we can continue, and this is what folks are doing in the Kubernetes world, and they're doing an awesome job, and their work is very impressive. Just continuing to allow that work to happen and supporting open source development, giving people the time and space and the dollars to do that, to help bring changes like my volume growth example more natively into Kubernetes, where you can just like change that volume spec in your Kubernetes manifest, and then the volume grows. It's kind of back to your point, Mike, about being able to do cluster things like upgrades and not have to be aware of the secret life of storage behind the scenes. So continuing to improve on that as we are is awesome.
All right, Ivan, let's play theoretical. You have been appointed king of all things Kubernetes storage. What's the one thing you would fix or change, or with a wave of a wand say, hey, this is all going to be better tomorrow?
Really, my answer is actually what I just described, to be honest with you. So as boring as it may be, I'm not really in a position to judge much the work that the folks that are actually making these improvements to Kubernetes storage world are doing. Even though I'm very informed about like the things we've been talking about, I certainly can't pretend to be in the Kubernetes keps and the code and so on the way these folks are. So I admire the work that these folks are doing, and I think that if I could wave a magic wand and make something happen, it would be helping to support these folks and these companies in an even bigger way, so that they could be freed up to continue to do this work, because I think they're doing a great job.
All right. Are there things that you see people doing when they're first starting out that make you kind of just shake your head and go, wow, I wish you hadn't done that? Or are there places where you could give some best advice to folks about, there are gotchas to look out for that you just don't want to do early because you'll pay for them later?
Yeah, sure. I'll just rattle off a bunch of stuff. So some of this is going to be repeat, but it'll be a good summary. Like I said earlier, you start with stateless apps first. It lets you operationalize Kubernetes in your organization, become comfortable with it, let Kubernetes become prolific and a mainstay part of how you deploy apps, how you troubleshoot, how you fight fires, and let yourself become used to Kubernetes as a platform. Also, acknowledge the undertaking and the cost and the risk and the paradigm shift that happens in an org when you are moving to containers, moving to Kubernetes, and also moving into, now we've Kuberneted, we've containerized a bunch of apps, and we're ready to start doing storage. It's cool if we have a bunch of people that are a subset of the org that are gung-ho and can get this work done. That's hugely valuable, but it's also really important to get buy-in and to attach this work to organizational goals, and make sure you've got time and money and resources, and that you can share the knowledge and all of the perspective with everybody, so that we're not creating like engineering hotspots and burnout and all that kind of stuff. Your business is your data, probably, right? And so make sure that you're connecting the right people into this equation that care about the data, because everybody feels better when they're included about, you're moving my data where? You're doing what to my data? Part of the business goals point is what problem are we solving? What are we improving by doing this? Hyper-converged storage is awesome and the most flexible way to get things done. But back to connecting that with business drivers is important. Acknowledge that migrating your first stateful app to Kubernetes might feel like a few steps back, because it is. You're learning new things. You have to answer a lot of questions about your app. Do other apps need to access this same data? Will I have to migrate multiple apps that share the same data? Do related cron jobs or other processes like secretly go in and like touch that data in the night? That's part of some important, bank transfer that we make. Do we need to re-architect anything to make best use of our platform and our storage? So the last thing I'll say here is that if folks are earlier in their Kube journey, the maturity model that I mentioned, that you can go to fairwinds.com and check it out, and it's also available via the CNCF, I believe, is a nice guide, and doesn't mean you have to fit exactly in one particular bucket, but it's a neat thing to read because it helps you get a sense of the different levels of evolution that you can have as an org going on your Kubernetes journey. One of the things that model talks about is it's often common to go back to an earlier point in the journey as you migrate new apps. And this is definitely the case for storage as well. You might be at like a level 6 on your journey on this model, and you're going to go down to like 4 or 3 for this kind of thing. So that was the lightning round. Hopefully some of that was useful to you all to help you move into your next steps.
Great. And of course, even after you get it all set up and it's perfect, don't forget about data protection, because there's a guy named Murphy and he has a sense of humor and he will come and mess with your cluster. Yes. Hey, Ivan, thanks for sharing your knowledge and expertise.
Yeah, thank you very much. It's been great being here.
All right, Cody, we're handing it back to you.
Well, Mike, thank you so much for leading our discussion today. And Ivan, thank you so much for your generous contributions. I learned a lot from today's discussion, so thank you both. I'd like to remind our audience today that this session was in fact recorded. So following this panel, you'll receive an email with a link to access that recording on demand. You can also find the recording living on the Container Journal website at containerjournal.com/webinars, and just be sure to look in the on-demand section. So on to the 4 winners of our $425 Amazon gift card drawing. Our first winner is Jadeo4O. Our second winner is Christoph K. Our third winner is Dave R. Our fourth and final winner is Sakti D. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim that gift card. But if you don't happen to see that email, just check your spam folder. So to our audience, we really appreciate you spending time with us today. And we ask for 1 extra moment of your time to fill out a brief survey that will pop up on your screen here in just a moment. Otherwise, we hope to see everyone at an upcoming Techstrong learning program. Everyone, have a great rest of your day. And Ivan, Mike, thank you once more.
Thank you, Cody.
Thank you, guys. Take care.
Take care.